Today we will study chapter 3, laws of motion. Here in this chapter we are going to study Newton's law of motion. Topic 2 will be friction and topic 3 will be uniform circular motion. Under this chapter we are going to study the general concept of force, inertia, Newton's first law of motion, momentum, Newton's second law of motion, impulse, Newton's third law of motion, law of conservation of linear momentum and its application, equilibrium of concurrent force, friction, static and kinetic laws of friction, rolling friction, lubrication, dynamics of uniform circular motion, centripetal force, example of circular motion, vehicle on level, circular road, vehicle on banked road. Firstly, we'll go through the first topic, which is Newton's law of motion. So, according to the first topic, Newton's law of motion, here, force, inertia, these are the important keywords for the laws of motion. So, inertia, the inherent property of objects that do not change their state of rest. The thing is, the inherent property of an object that do not change their state of the rest or uniform motion along the straight line path unless the act upon by an external force is called inertia. Okay, just the state of any object which is not changing its position or any uniform motion is there as until or unless any external force has been not applied to that particular condition is called inertia. The inertia of the body of three types: inertia of rest, inertia of motion and inertia of direction. Now, Newton's first law of motion. There are three laws of motion. So firstly we go through the Newton's first law of motion. An object at rest tends to stay at the rest of an object in the motion tends to stay in the motion the straight line with the same speed or the direction. It is compelled by some external force. In simple language, if any object is there, okay, and we are not applying any kind of external force, then it will be remain same position until or unless any external force has been applied. So this will be Newton's first law of motion. Now, the linear momentum. The product of mass of velocity of the body is called linear momentum. It's a very simple thing that the product of mass, it means m, and the velocity b of any body is called linear momentum. We can say p is equals to mv as well. And it is a vector quantity. Its direction is same as the direction of velocity. It is represented by p, and thus m is the mass and v is the velocity. Then as according to the statement, its mathematical expression will be p is equals to mv. If unit of the mass is kg, unit of velocity is meter per second, then the unit of momentum will be kg per meter second. Now, Newton's second law of motion. The rate of change of linear momentum of the body is directly proportional to the applied force, and this change takes in the direction of the applied force. We can say F is directly proportional to dB upon dt. dB means a change of linear momentum with respect to the time. Then d upon dt, we just put the value of p, then F is equals to kma. When k is equals to 1, as it's experimentally proved, then F is equals to ma. This will be the mathematical expression for the Newton's second law of motion. Now, this page is representing the laws of motion, what all keywords which are going to play a pivotal role in this particular laws of motion, like centripetal force, centrifugal force, friction, momentum, impulse, Newton's law of motion, all the three laws, inertia and etc. Let's move forward. Now, the relation of the ballot as long as the speed is not, as v approaches the speed of light, it is just simple, the Newton's second law of motion only. Now, impulse. The quantity or the physical quantity that is used to get an idea about the change in the dynamic state of moving particle, this is impulse. Mathematically, the impulse is the equal to the product of the force and a small time interval for which it acts as an impulse. So mathematically, I will be equals to F and delta t. F is the larger magnitude and delta t tends to 0. So I will be is equals to F. I will be equals to m delta v, then m v minus u in initial and the final velocity, then it will be equals to delta p. So delta p is a change of momentum of the body. Now Newton's third law of motion. To every action there is an equal and opposite reaction. Okay, It means all the forces in the universe occur in the pair. It is important to remember that action and reaction never act on the same body. It means F12 or F21 will be equals to 0. We can say if F12 is equals to minus of F21. In short, if there is an equal and opposite reaction for every action, this will be the Newton's third law of motion. Conservation of linear momentum. In the absence of external forces, the total momentum of the system remains constant and does not change. F tends to 0, then dp upon dt is equals to 0, then p is equals to constant, where p is the momentum vector. So this will be the conservation of linear momentum. Now we'll deeply study mass and force, etc. with the help of some free body diagram. Okay, different cases applied on the second and the third law of motion without friction. See, we have one block and here N and mg. Then F will be equals to m into g. N is equals to mg as in place of acceleration, gravitational force is being acted. Okay, now another diagram is there, N and mg same, but now here force has been applied. Okay, then N is equals to mg or F is equals to m and a. As force is being applied, it means obviously acceleration will be there. Now moving to the next, if two forces has been acted, here only one was there, now F2 and F1, and in this case F1 is greater than F2, so N is equals to mg, as it will be two forces has been acted, so F1 minus F2 will be equals to ma. Now when two different forces has been acted, that's fine, but also angle has been made there. So at that condition, if you can see N, mg, F1, F2, that's fine. Now there is one angle, okay, and two components. It has been divided in two components, F1 sin theta and F1 cos theta. Okay, then here N will be equal, N plus F1 sin theta will be equals to mg, and F1 cos theta minus F2 will be equals to ma. Okay, now moving to the next, there will be a slope diagram will be there. Then another components will be f sin theta or mg sin theta, we can say, and another component is mg cos theta. So N is equals to resultant force will be equals to mg cos theta, and mg sin theta will be equals to ma. Another, now N is there, mg sin theta, mg cos theta, mg is there. Now this side in opposite direction one more force has been acted, okay, and also angle which is when it is theta. Then N mg cos theta is equals to F, as F is been acted over here, so F minus mg sin theta is equals to ma. Now two different masses blocks are there, then obviously mass has also been divided m1 and m2, and to n1 m2g m1g, then n1 is equals to m1g, n2 is equals to m2, then F minus T will be equals to m1a, then T will be equals to m2a. Okay, so these are some few conditions with respect to free body diagram for second and third law of motion. Now concurrent forces. If all the forces working on the body are acting on the same point, then they are said to be concurrent. What actually concurrent means? If all the forces are on the body acting on the same point, then they are said to be concurrent. A body under the action of concurrent force is said to be equilibrium when there is no change in the state of uniform motion along with the straight line. The necessary condition for the equilibrium of a body under the action of concurrent forces is the vector sum of all forces acting on the body must be 0. Mathematically expression will be like, see, force net or total force is equals to 0, then Fx will be equals to 0, Fy equals to 0, and Fz equals to 0. Three concurrent forces will be equilibrium if they can be represented completely by three sides of triangle taking an order. Okay, like this: A, B, C, F1, F2 and F3. Lami's theorem for three concurrent forces equilibrium, F1 sin alpha is equals to F2 sin beta is equals to F3 sin gamma. Three angles have been made there, alpha, beta and gamma. So the Lami's theorem will be this. Now on the basis of these, we will go through with some 1 marks question. The term inertia was the first used by Galileo. Okay, Galileo has first used this inertia term. A ball is traveling with the uniform translatory motion. This means that all the parts of the ball have the same velocity. See, in uniform translatory motion, all the parts of the ball have the same velocity. As uniform is there, so we'll conclude that same velocity will be there in the magnitude and direction is constant. So option C will be the correct. All the part of the ball have same velocity, magnitude, and the direction. The velocity is constant. Now, for which of the following cases the net force acting body is not zero? A drop of rain falling down with a constant speed, a cork mass 10 gram floating on the surface water, a car moving with a constant speed 20 km per hour, and a pebble of the mass 0.05 kg is thrown vertically upward. So obviously as upward direction is there, so in this case only force will not be the net force acting on the body is not the zero. Explanation: see, in the option net force is not zero because the acceleration is not zero. In all other option, velocity is constant, has the acceleration is zero, so the force is also zero. But when we see in the upward direction case, the force will not be zero. So option D will be the correct. Now, one numerical based question: a bullet of the mass 40 gram moving with the speed of 90 meter per second enters a heavy wooden block stopped after a distance 60 centimeter. The average resistive force exerted on the block bullet is. So firstly we have a velocity, initial and final, 90 meter and final is 0. Mass is also there, will convert it into the kg, and s is distance is 60, will convert it in meter. So we'll use the equation, third equation of motion, v square minus square equals to 2s, as we have to find the force. So substitute all the given values. A will be equals to, we'll get minus 6750, as we have to calculate force, means F is equals to ma. So 670 and the m we already have, so we'll get the force 270 Newton. On the basis of the mathematical expression of loss, we'll have to find all these values. Now, the spherical ball of the mass is 10 to the power minus 6 kg hits a ball 1000 times per second normally with the velocity 1000 meter per second and rebounds with the same velocity along with the initial direction. The force experienced by the ball is. So here explanation is like, see, for experience by the ball can be described as the change transfer to the ball. So delta p is equals to mv. We also we already know the momentum law. After that it will be, we'll just substitute the values, and here we get delta p is equals to minus 2 into 10 to the power minus 3. So momentum change transferred as well as p net is equals to 2 into 10 to the power minus 3. As it gets changed, so it will be positive, then it will be equals to 2 kg per meter second. So force experienced by the wall F is equals to delta P upon dt. We'll put the value 2 upon 1. It means force experienced will be 2 Newton. So option C will be the correct one. Now, a passenger is moving and the bus thrown upward. A passenger is moving, bus is thrown forward when the bus is suddenly stopped. This is explained by the Newton's first law. It will be remain same if first law, if any force is not been applied. So option A will be the correct. A bullet of the mass 25 gram moving with a velocity of the 200 centimeter per second is stopped with the 5 centimeter of the target. The average resistance of a target is. So we have F is equals to ma. We already know. We substitute the value, and then we also know that v square is equals to minus u minus 2s. Then u is equals to 2. So value of a we get. When we substitute the value of a over here and we solve this particular equation, we get F is equals to 10 kilonewton. Okay. Now moving to some another 2 marks question. When the current is turned off, why does electric fan spinning for the while? We know that when we switch off the fan, it just keep on continuously moving for a while. Why so? A fan continues to rotate due to the inertia of motion until the friction is being, and that air brings to the rest. External air has been applied just to keep fan on the rest. That's why until it applied, it just keep on moving for a while. Okay. A person left on the frictionless surface wants to get away from it. How he can do? He can get away from the frictionless surface by blowing air out of his mouth. Okay, by throwing some of his heavy object in the direction opposite in which he wants to move. With the help of this, he can move from the frictionless surface. Now, moving to the 3 marks question. Air is thrown on a sail attached to a boat from an electric fan on the boat. Will the boat start moving? No. See, when a fan pushes the sail by the air, then the fan will also experience the force in the opposite direction. Since the fin is also a part of the body, is a part of the boat, then the vector sum of the momentum of the fin and the boat is 0. So the boat move only under the reaction when some external agency will be there. A soda water bottle is falling freely with the bubbles of the gas rises. The water bottle. Will the bubble of the gas rise in the water of the bottle? So bubble will not arise in the water. The water in the free falling bottle is in the state of weightlessness. Okay, no weight will be there. Hence the pressure in the water does not increase with the depth, therefore no upthrust on the bubble, which therefore does not rise up. Okay, this is the reason. Now some lengthy questions. Write and explain the conservation of linear law of momentum. Give two example based on the conservation. If no external force act on the system called isolated system. Of a constant mass, the momentum of the system remains constant with the time. So we know that according to the law for a system, F is equals to dp upon dt. In the absence of external force, F is equals to 0. Then P is equals to constant. So P will be equals to P1 plus P2 plus P3 and so on. So P is equals to MB, so M1, V1, M2, V2 equals to constant. This equation shows that absence of external forces closed by the linear momentum. Individual particles change by their sum and they remain with the time. So the law of conservation of linear momentum is independent of the frame reference, though the linear momentum depends on the frame of reference. Conservation of linear momentum is equivalent to the Newton's third law of motion. Two examples based on the conservation area. When a man jumps on the boat, okay, on a shore and the boat is pushed slightly away from the shore. A person left on the frictionless surface can get away from it by blowing air on the mouth or by throwing some object direction to the in which he wants to move. So this is the example, conservation law of linear momentum along with some examples. Now, define the impulse of the force, write the unit and prove the impulse of the force, simply change the momentum. When a large force works on a body for a very small time interval, it is an impulsive force. An impulsive force does not remain constant but change first from the maximum and from a maximum to 0. In such case, we can measure the two effect of force. The impulse of the force is measure of the total effect. It means I is equals to from T2 to T1 and F dt. The impulse of the vector quantity, its direction same as force. Dimension formula is MLT. Unit is kg. M meter per second. It's SI unit. CGS unit. From the Newton's second law of motion, we draw the graph between F and T, force and the time. We get F is equals to dp upon dt. Then F dt is equals to dp. So I will be equals to P2 minus P1. It means delta P. So the impulse of the force is equals to the change of momentum. Here from here we can see I and then delta P. It means change of momentum. This statement is known as momentum impulse momentum theorem. It means it depends on the momentum. Now let's move forward with the second topic, which is friction. Now, what actually the friction is? If we slide or try to slide a body over the surface, the motion is resisted by the bonding between the body of the force. The resistance is represented by the single force, which is called friction force. The force of friction is parallel to the surface and opposite to the direction of intended force. There are some types of friction. Firstly is static friction, the opposing force that comes play when the body tends to move over the surface, but actual it has not started the static friction. It is self-adjusting friction. You just keep in mind that the static friction is self-adjusting frictional force. Limiting friction is if applied force is increased. Okay, we have applied any kind of force and it's been increased. The force static friction is also increases. If the applied force exceeds the certain maximum value, the body start moving. The maximum value of the static friction up to which the body does not move is called limiting friction. Very easy language, that is maximum value of the static friction up to which the body does not move is called limiting friction. Now, kinematic or the dynamic friction, if applied force is increased for the set of body in the motion, the friction opposing to the motion is called kinetic friction. Means Fk is equals to mu k r. Then mu k is just nothing but the coefficient of kinetic friction. There are some types of kinetic friction: sliding, rolling, and the angle. From this word we can see it's a sliding friction, the rolling friction. The opposing that force comes into the play when A body is actually sliding over the surface, and other body is called sliding friction. A flat block moving over the horizontal table is sliding. Rolling, when a body is in the vehicle, its wheel, disc, etc., sphere, cylinder, the force of friction that comes to play under is called rolling friction. Now, angle of friction. Angle of friction may be defined as the angle which is the resultant of limiting friction and the normal friction with in a diagram below. So we have one block here. N is the resultant force, then F and S, and then P. P is applied force and is the normal reaction force, and F is the friction force, S is the resultant limiting friction. Then theta will be equals to 10 inverse mu L. Angle of repose. The angle of repose is defined as the angle of inclined plane with the horizontal at which the body placed just being to slide. Advantage and disadvantages of friction. Advantage of friction is, this is something important, like walking, it's possible due to the friction obviously. Two bodies stick together due to the friction. Brake works on the basis of friction. Writing is not possible without friction. The transfer of the motion from one part to machine to other part is possible only by the friction. And the disadvantages is, the friction always opposes the relative motion between any two bodies in contact. Therefore, extra energy has to be spent in overcoming the friction. This reduces the efficiency of the machine. Friction causes wear and tear part machinery in the contact. Thus, there is lifetime reduces. Friction force result the production of the heat, which causes damage due to the machinery. Method of reducing friction is, we can use polishing, lubrication, proper selection of materials, streamlining the shape of the body by using bearing. Also, we can increase the friction by throwing some of the increase the friction throwing some sand on the slippery ground. And in manufacturing of the tires, synthetic rubber of the preferred because its a coefficient friction with the road is large. Now moving to the 1 marks question. Which of the following description of the friction is incorrect? There are some options. The coefficient of the friction between the given pair substance is largely independent of the area contacted between them. The friction force can never be exceed reaction force on the body support. Rolling friction is only slightly smaller than the sliding friction. The main source of the friction is irregularity of the surfaces in contact. So firstly, which is that this is incorrect. So rolling friction is much more than sliding friction. So the friction is only the slightly smaller because according to the friction law, rolling friction is only the slightly smaller than sliding friction. No, it's not the it's incorrect actually, the description of friction. So that's why option C is the correct one. On horizontal road, an automobile accelerated by applying a force against the force applied by the road on the car. As when the car moves, friction force acts against it. That's why when on a horizontal road, automobile accelerates applying the force applied by the road on the car. A numerical based question. A body slipping down an uneven steeply inclined surface 30 degrees off an horizon where there is a 0.26 coefficient of friction. The acceleration meters per second is. So as we know, A is equals to G sin theta mu K cos theta. We'll just substitute all the values of theta. We have different degrees as well, means angle degree. Then when we solve it, we get A is equals to 2.69. Or we can write it as 2.7 in the round figure. So this will be the acceleration value. Now, a mass of 1 kg for horizontal surface in a truck, the surface and the block have a static friction 0.06 where the truck accelerates the rate, the frictional force exerted on the block will be. Then we know that F is equals to mu L mg, we have already started. Then 0.06 we substitute the value, we get F is equals to ma, then 1 into 5, or we get force value is equals to 1 Newton. Moving to the next 2 marks question. Why it is difficult to walk on the sand or the ice? When we press the sand by our feet in a backward direction, the sand gets displaced very little. With the result, with reaction from the sand is very small, hence we cannot walk. And another case is ice. There is very small friction between feet and the ice, which gives the rise to every small force reaction, and it's difficult to walk. There is not good friction between the ice and the feet. That's why. Now, Moving to this third 3 marks question. Why does a children in a merry-go-round press the side by seat radically upwards? As a child presses the side of his seat radically outwards, the side of the seat presses the child radically inward in the direction, means opposite direction, thus the providing him required centripetal force of the circular motion. Now, some 5 marks question. We have firstly define angle of acceleration and angle reposes. Obtain the relation between angle of repose theta is equals to tan inverse mu. Firstly, the definition angle of friction, it is the angle which the direction of the resultant force of friction and the normal reaction makes with the direction of normal reaction. It is represented by theta. It means tan theta is equals to mu. What is angle of repose? The minimum angle. Just check the minimum angle of inclination of the plane with the horizontal theta s, at which the body's place just begins to the slide down. It is called angle of repose. So we have derivation. If we can see in a figure, a block is placed in the inclined plane, the angle is theta with a horizontal plane. Okay, since the block is in equilibrium, the net force of the block is, we can see, this is the diagram. We have to component mg cos theta, mg sin theta, force mg, then theta. Fs is equals to mg sin theta and r is equals to mg cos theta. Then Fs is equals to mu s into r. We'll substitute the value and we get the resultant r is equals to mg sin theta s. Dividing, we get mu s is equals to tan theta. Then theta s will be equals to tan inverse mu s. Now, another is an automobile is moving on the straight horizontal road with the speed u. If the coefficient of the static friction between the tires and the road is mu s, what is the shortest distance in which the automobile can be stopped? Let A be the deceleration of the automobile and S be the stopping distance. Then V square minus, from the equation of motion, we get S is equals to E square upon 2A. By the second Newton's second law, F is equals to ma. Then Fs is equals to ma. Then Fs will be equals to mu s into r or mu s into mg. We get A is equals to mu s into g. By the equation 1, S is equals to, we get u square upon 2 mu s into g. Now, let's move to the last topic, which is uniform circular motion. Here, firstly, displacement. The change of position vector of the displacement is theta. The particle from the position A and B is given to the referring, like see, we have one diagram. Okay, A and B are the two different positions. Velocity is v1, v2. Angle is theta. Resultant versus r1 and r2. So here we get delta r is equals to r2 minus r1. We can write it as mod of delta r is equals to mod of r2 minus r1. Or resultant, we get delta r is equals to under whole root of r1 square r2 square minus 2 r1 r2 cos theta. When you put the value of r1 and r2 is equals to r, we get delta, we just put all the values and here we get delta r is equals to 2r sin theta by 2. Now same for the angular displacement. Here, the angle traced by the body moving in the circle from some reference line to is called angular displacement. Dimension formula m0, l0, t0 as theta is equals to arc upon radius. Unit is equals to radian or degree. Sometimes it also specified in the term of multiple of revolution. 2 pi radian is equals to 360, which is equals to 1 revolution. Angular displacement, it is an axial vector quantity. Now, same angular displacement, angular velocity. Angular velocity is denoted by omega of an object is a circular motion is defined as the time of rate angular displacement. Angular velocity is equals to angle tracked upon time taken. So, it will be Lt theta t upon t, d theta upon dt. So, omega will be equals to d theta upon dt. This is the mathematical expression of angular velocity. Its dimension formula, unit is radian. Angular velocity is an axial vector. Now, angular acceleration. Angular acceleration of an object is a circular motion is defined as the time rate of change. Its angular velocity. Then delta omega is the change of angular velocity of object. Time interval is delta t, and while moving to the circular path, see here, the time interval delta t moving the circular path, the angular a will be, this is an anti-clockwise direction, then alpha will be equals to L delta omega upon delta t, then it means it will be equals to d square upon dt square. This will be the mathematical expression for angular acceleration. Unit is there, dimensional formula is there, relation between the linear acceleration and angular acceleration. A is equals to alpha into r. For uniform circular motion, its constant alpha is equals to d omega upon dt is equals to 0. Now also some terms we need to know for the circular motion. Its period, it's t. In the circular motion, the time period is defined as the time taken by an object to complete one revolution in circular path. Unit is second. Dimension is m0, l0 and t. Only t as a time only there. Period of the second hand watch is equals to 60 seconds. The minute of the hand watch and duration is 60 minutes. The hour end of the watch has a duration 12 hours. Moving to the next. Its frequency. In a circular motion, the frequency is defined as the number of revolution completed by the object. Circular means n is equals to 1 by t. Unit will be hertz. Dimension will be m0, l0 and t inverse. That's 1 upon t. Now, another thing is centripetal acceleration. Acceleration acting on the object undergoing the uniform circular motion. It's called a centripetal acceleration. It is always acts along with the radius toward the center. Center is everything for the centripetal acceleration. Magnitude of the centripetal acceleration is equals to v square upon r, which equals to omega square r, or which will be equals to 4 pi square upon t square r. The direction of the centripetal acceleration, it is always towards the center, as I already mentioned. Now the centripetal force is that force which is required to move in the circular path with the uniform speed. The force act on the body along with the radius toward the center. Then F is equals to mv square upon r. Then it will be equals to m. When we just put all the values, we get m 4 pi square upon t square r. Now, banking of roads. To get the centripetal force, the cyclist went towards the center of the circular path is not possible in that case for of four-wheelers. To prevent a vehicle from the traveling straight ahead, the road outermost is raised. This is the vehicle resultant force, and then mg is a force. Another angle, two component r cos theta, r sin theta. Angle made is r and then theta. Okay, so two figures are there, and another is this length L, distance S and height H. So the reaction, figure A shows the reaction resolved into the two component, and r cos theta balances the weight of the vehicle. So r cos theta is equals to mg, and in the horizontal component r sin theta provides the necessary centripetal force. It's directed towards the center of desired circle. So r sin theta mv square upon r. Then we'll divide both the equations. We get tan theta is equals to v square upon rg. Tan theta is equals to, we'll put the value of angular velocity, then omega square r upon g. We get v omega upon g as v is equals to rw, r omega. Then if L is width of the road, h is the height of the outer edge, as it's already in the figure B, then tan theta will be equals to hx, which is equals to h upon L. So from the equation third, equation fourth and the equation fifth, we can conclude tan theta is equals to h upon L. When the friction present in the tries to road, then v square upon rg, which is equals to mu plus tan theta upon 1 minus mu tan theta. So maximum safe speed of the banked friction will be v r whole under root of rg mu plus tan theta upon 1 minus mu tan theta. This is an important expression. Now, on the basis of this topic, we'll just go through with some more questions like objective ways. So cyclist leans as he or she turns to generate a required centripetal force. Centripetal force is being required for cyclists to lean. Okay, as a turning means a curved shape, and which requires a centripetal force. Bending will generate the required centripetal force. A particle is moving on the circular path 10 meter at the radius, and the instant speed is 5 meter per second. The speed of the increasing rate is 2. The magnitude of the acceleration will be. Here we know that r is equals to 10, v is equals to 50, a1 is equals to 2. So a1 is equals to v square upon r. We'll substitute the value, we get the value of acceleration 2.5. Therefore net acceleration, it's saying we already have one acceleration, another is 2. When we solve this, we get 3.2 meter per second square. So this is about this particular numerical. Now another one is that a particle is moving in the circle describing equal angles in the equal time. Its velocity vector will be, its velocity change the direction. One particle is there, it is moving in a circle, okay, and describing an equal angle. It's making an equal angle, equal time, and its velocity vector will change with the time. Also, a tachometer is a device which is used to, tachometer is a device used to measure a speed of rotation. 2 marks question. We have a two particle equal masses and are revolving in a circular path of the radii r1 and r2 respectively with the same speed. What is the ratio of the centripetal force? F is equals to m square upon r. M and v are the constant. Then F is directly proportional to 1 upon r. Now F1 upon F2 is equals to R2 upon R. This will be the two particles which are having the equal masses. So this is the ratio of the centripetal forces. Now find the linear velocity. Omega is equals to 3I cap, and then this. We know that V is equals to omega into R. We'll substitute the values and we solve this matrices. We get 18 minus of 18I cap, minus of 13J cap, and plus 2K cap. Now moving to the 3 marks question. We have a particle of P is moving in the circle of the radius A with a uniform speed B. C is the center of the circle. AV is the diameter. When passing through the V, what is the angular velocity P and C? About to A and C. Angular velocity of the particle P about A. Omega is equals to V upon RAB. V upon 2R. The angular velocity of the particle P is point C. So omega C will be equals to B R V C upon V upon R. When we check out the ratios, as we have to find the ratio only, so we get V upon 2R, V upon R. When we solve this, we get 1 by 2. So the ratio will be 1:2 or 1 by 2, we can say. Now 5 marks question. Here, what do you mean by the banking of road, and derive the expression for the angle banking of the road? Firstly, to get a centripetal force, cyclist bent, as we have studied in one objective as well, for the leaning towards the center of the circular path, and it's not possible case for the four-wheeler. Therefore, the outer bed on the road is raised so that the vehicle is moving automatically inclined towards the center. But we have to find the angle. How? So we have this vehicle, we have this component r cos theta, r sin theta, r and mg. Another one is this. So figure A shows the reaction r cos theta is equals to mg, and another is r sin theta. This horizontal component provides the necessary centripetal force. It is directed to the center desired circle r sin theta mv square upon r. When we divide both the equation, we get tan theta v square rg, or we simplify this equation and we get tan theta omega square r upon g, then v omega upon g. Then we get L is equals to, with h is the height of the outer edge, then we get tan theta is equals to h upon x, or is equals to h upon L. From all the equation 3, 4 and 5, we get tan theta is equals to h upon L. Now we have some numerical based question as well on the basis of the topics we have studied. 3 blocks are there, 2 kg, 3 kg, 5 kg are connected to each other with the light string and then placed frictionless as shown in the figure. The system posed F is equals to 10. Then find the value of tension T1. Different blocks, their force, we have to find the T1. Acceleration is 10, means 10 upon total mass. 10 by 10 means 1. Therefore T1 is equals to 5 plus 3 into 1. Then we get T is equals to 8 Newton. Two forces with the equal magnitude F act on the body, and magnitude of the resultant force is F by 3. What is the angle between the two forces? Then F net we know F1 square plus F2 square, 2 F1 F2 cos theta. We'll substitute all the values, F upon 3, like whatever values we have from the question. Then we get the angle value theta is equals to cos inverse minus of 17 upon 18. We have one more question. A gardener water the plants with a pipe of the diameter 1 mm. The water comes out the rate of 10 centimeter cube per second. What is the rectilinear force that hangs on the gardener? So rate of flow of water is V upon T. It means 10 upon 10 centimeter cube upon second. Then it is equals to 10 into 10 by minus 6. We convert it into the meter. The density of water rho is equals to 10 raised to the power 3 kg. Then cross section of the pipe A is equals to pi 0.5 into 10 raised to the power minus 3 its whole square. We also know force F is equals to mv upon T. Then V is equals to rho PV. Then rho V into rho upon T, V upon 80. We just solve it, and V is equals to V upon 80 we know. When we substitute all the values, we get force is equals to 0.2127 Newton. Now a body of mass 8 kg is moved by the force F is equals to 3x. Where x is the distance over covered, initial position x is 2 meter and then final position x is 10 meter. The initial speed is 0.0. What is the final speed? So increment in kinematic energy work done, half mv square minus v square. Okay, as initial and final both velocity are there. then which is equals to t2 x1 to x2 f dx. Then we put the value when we solve both the equations, right hand and left hand side, then we get the value of v is equals to 6 meter per second. This will be the value of final velocity. Okay, so these are some few questions which are again based on this equations only. A ladder weight is weighing 250 Newton and is placed against the smooth vertical wall. If the coefficient of the friction between the floor is 0 point, then what is the maximum force friction to the point contact between the ladder and the floor? So friction can be calculated using the formula F is equals to mu r. When we substitute the value, we get force is equals to 75 Newton. These all are based on the mathematical expressions which we have derived or followed. Now, a block of the mass m is 5 kg on a rough horizontal surface for which coefficient of the horizontal is 0.2, when the force F is 40 Newton applied to find the acceleration of the block. So here we have, I will just draw the diagram according to the need. When we get m, angle is 30 and F is force is F. Kinetic friction is mu r. Then we just substitute the value 0.2 mg minus F sin theta. When we solve this, we get F is equals to 6 Newton. Okay. Now, according to the Moore second condition, it will divide in two components, F sin theta, cos theta. Then acceleration of the block will be F cos theta minus kinetic friction upon the mass. And then force 40 minus root 3 upon 2, we substitute the value and we get acceleration is equals to 5.73 meter per second square. Now we have another case based question. We have some cases and on the basis of that we'll have to answer few questions. Also some subjective question, like we have some subject: when a vehicle moves around the level curved road, the force of the friction between the tires and the road provide to the necessary centripetal force. If the frictional force is not enough to provide the necessary centripetal force, the vehicle skid. In order to avoid the skidding, the outer edge of the road raised for the level of the inner edge. This is known as a banking curve. A cyclist bends slightly to center of the circular track in order to save without slipping. Diagram has been given to us. Okay, cyclist taking the turn towards the right on the circular path, radius is r, mass is m, cyclist with the bicycle, velocity v. When the cyclist negotiates the curve, he bend inwards to the vertical angle q. Let r be the direction of the ground of the cyclist and r has a into two component, r sin theta towards the center of the curve providing the necessary centripetal force. Second is r cos theta balancing the weight. On the basis of this subject, we have few questions. Like when the car travels in the level of the circular motion, how does the necessary centripetal force develop? The necessary centripetal force is developed by the force of friction between the tires. Condition of skidding is when centripetal force is greater than frictional force. We substitute the value mv square upon r mu mg, then v square upon rg mu. We get tan theta which is greater than u. So this will be the condition of skidding. Banking of curved road. To provide the necessary centripetal force, the outer edge of the curved road is raised above to the level of the inner edge, and this is known as banking of curved road. A cyclist, while negotiating a circular path, speed is 30 meter per second, found that he has to bend an angle 30 degree with the vertical avoid skidding. What is the radius of the circular path? Tan theta is equals to v square rg. Then tan 30, we substitute the value of theta and all, then we get value r is equals to 159 meter. So this is all about this chapter. And also we have some assertion and reason based questions. So assertion is there, we'll have to find whether r is relatable to a or not, whether a is true, r is false, a is false, then r is true, like this. Impulse has a dimension of the linear momentum, and this is the assertion. The reason is impulse is equals to force into time. So here we can see both A and B are true, that yes, that impulse has a dimensional linear momentum, and also impulse will always equals to force into time. So dimension of the impulse, the linear momentum is Hamilton inverse. So assertion is true. Here we concluded, and also we, as it's related to the force in the time, so the reason is also true. It does not explain. Impulse is equals to force into time. Okay, wait, see. Impulse has a dimension for the linear momentum. Let's check first this, that dimension of impulse is equals to dimension of linear momentum, then LT inverse there, so it is correct. But when we talk about that impulse is equals to force into time, it was not like that, that F into T is equals to impulse, because the reason is also true, but it does not explain the assertion. Reason is true, that's fine, but when we see the relation between the assertion and the ratio, so it's not correct. Here we can conclude that option B is the correct. Both A and B are true, but they are not correlated to each other. Okay, so like this you can go through with the other questions as well. This is the self-assessment paper where you will have to solve all the question on the basis of the mathematical expression, on the basis of the law we have studied. So this is all about the chapter 3. Stay tuned for the chapter 4. Thank you.